So next, I'm going to talk about combination gas valves. A lot of people say, Ty, why do you say it as a combination gas valve? And I say it because I want everybody understanding that it's two components. So here is a very old gas valve set, and it's not just a gas valve. We have a solenoid valve that opens and closes to change the flow of gas, and we have also a pressure regulator. So this drops the pressure down, and this opens and closes for the flow of gas. So notice there's two separate components. Nowadays, even though we have the advancement of technology, it's in one single component, much smaller, much easier to work with, but it's still a combination of a pressure regulator and a solenoid valve. That's extremely important while we're doing work on these and diagnosing these. You have to remember that there's two components inside of here, so there's two steps for diagnosing this. Now, I love this old one. I keep it for memorabilia purposes, but I hated working on these because there was few safety components, and it was just a nightmare to work on. But while we're looking at it, look at these massive manifolds and these massive spuds, even though the orifices weren't all that big. Just love these old systems. But next we're going to go through and talk about all these different gas valves. Here we have our modern combination gas valve. It's a combination of a pressure regulator and also a solenoid valve. If you see here, we have two solenoids, our main solenoid and a redundant solenoid. The idea is that both of these have to open to allow gas to flow. It's a redundant valve, so it allows it for, if there's a problem, it's 100% shut off. Both of these valves have to open to allow gas to flow. We don't want any chance of gas accidentally flowing while that system is off. Here we have a manual override switch, so that while there is a call for heating and you have an issue and you need to shut it off quickly, you can flip it to the off position, on and off. Normal running's on, and we're servicing or doing anything else, we can flip it off right there. All this off switch does is kill our 24 volts. I have this hot wired so it always has 24 volts on it, but we're going to take a look at a few of these things here shortly. Now behind this cap is our servo that feeds our pressure regulator. This cap must always be on. I've seen it before where people service these units, forgot to put this cap on, and this back here leaks. So this cap access our pressure regulator, our servo for a pressure regulator, and I screw this in to increase pressure, and I screw it out to decrease pressure. So we want to adjust the pressure according to our combustion analysis, clocking the gas meter, to what the manufacturer specifications say. It's typically 3.5 inches of water column for natural gas and 10.5 to 11 inches of water column for propane. There is a conversion kit changing this out between natural gas and propane, which also includes a spring behind this piece and also the spuds that are on the back side. So this is our solenoid side. When we take this top off, we have our solenoid right here. So what I'm going to do is hold this out. I lost a spring for it, but if we hold this out and I flip this to the on position, you can see how it pulls it directly in. It's not going to fall out. The magnet, the electromagnet, is holding it. If I try to pull it in, pull it out, it just pulls itself right back in. This is our primary solenoid valve, and there's another little one over here on this side right here. Now once I click this to the off position, we see that this plunger drops straight out. So this plunger has a rubber seal on it. So that's our solenoid side. It allows gas to flow or not to flow. This solenoid plunges right up against this port right here. So normally there's a spring forcing this closed, and when we have a call for heating, it pulls this open and allows gas to flow. So let's look at the flow of gas. Here's our inlet on the gas side, so it comes into this chamber right here. This is a screen that fits in like so. So the gas comes through and is ideally screened. In this particular model, the gas flows upwards so that any contaminants stay left behind in the bottom. Ideally, a drip leg should solve that before it ever gets to this component. So the gas flows up through the screen over into this chamber. If we have a call for heating, this chamber is opened by the electromagnet. It flows then from that chamber into this chamber right here. And from this chamber here, we have our pressure regulator, and that second solenoid actually controls the servo that allows the back pressure on this side. So it keeps this pushed down, so it has to have pressure on the other side for this to open. So we go through valve 1, valve 2, and into our pressure regulator. So if I turn this upside down, this is our true pressure regulator. Just an empty plate. Here we have our spring that keeps it forced in, and behind this diaphragm right here is our second chamber. And so here is the other piece that pushes up on this flapper. So that's our secondary. Now this little solenoid valve is piped all the way in to allow pressure on the back side of this for that to open. Also our servo on this little pressure regulator that we can adjust affects the pressure on this back side as well. From there, gas flows through behind this chamber into our pressure regulator, and from our regulator it flows out to our manifold. Now if I want to check the manifold pressure, we have a port right here. This port is hollow all the way through into this main chamber. So checking this port, this main chamber, is the same thing as checking it on a port here. In the old days, we actually had manifolds that had a plug right here, and we'd tap in to get manifold pressure right from that plug. Now the new ones, we have these ports right here on our combination gas valve. So this is our outlet or manifold pressure, and we also have another pressure port right here that's our inlet pressure. So this is going to be the gas coming in. Now the reason I harp on this being a pressure regulator and a solenoid valve is because you're going to have to diagnose it that same way. Just because my solenoid valve opens doesn't mean I'm going to have gas. Do you have the proper gas pressure coming into this? Do you have enough gas pressure coming out of that? So I typically check my gas pressure on the output side. I have a manometer hooked up. We take this tool right here, and what we do is on this plug, we'll do the inlet pressure since that plug's missing. Same service wrench for AC. We take and we back this out. This allows us to put our adapter here so we can check the gas pressure. Then we can use our typical manometer. We have our adapter that we put on there, and we can check our gas pressure. So if we don't have any gas coming in, it doesn't matter if I'm getting 24 volts for this to open. So I want to make sure, A, I have gas coming in. Next, I want to check, do I have voltage coming to this for this to open? So we have to wait for the proper sequence of operation. It's not just going to have 24 volts all the time. We have to know the sequence for the unit we're working on. So if I take my meter, set my meter up for volts, and we can turn the light on. And I take and check voltage here from one side to the other. We're showing 25 volts, so I do have the proper voltage, and we know it is in the on position, so my solenoid should be opening at that point. So now we know we have 24 volts to it. Now we can check gas pressure. If I do not have gas pressure coming out, it can mean one or two things. My solenoid is not opening, or there's not enough gas pressure coming in. So I would then shut this system off, shut the main gas off, check my incoming pressure. I do have incoming pressure, and I do not have outgoing pressure. Turn this back on, and I do, at the proper sequence, have 24 volts. We know that our solenoid inside is bad. So do I have solenoid, 24 volts opening at the proper location? Do I have gas pressure coming in? Do I have gas pressure coming out? The next thing is, you have the proper gas pressure coming in, and you adjust this, and you cannot get to the gas pressure you need coming out. Well, that's where you have a bad pressure regulator. I've seen people before try to adjust the gas pressure coming out, and they can't get enough gas pressure coming out, and they condemn this whole entire valve. You have to be mindful of gas pressure coming in. For example, let's say that the gas line coming in is clogged up. Maybe it's rusted up inside. When this gas valve opens, there's not enough flow coming into this. So because there's not enough flow coming into it, I'll never have enough flow coming out. So that's why they give us this port checking incoming pressure. Now typically, you don't have to check incoming pressure. You're going to be in a time constraint. You just check the output pressure. But when I can't get enough output, with adjusting it, I want to check input pressure. I also personally like to check the output pressure, the manifold pressure, while the hot water heater is on and also the stove is on. The reason is you'll have perfect gas pressure in your manifold side on a normal day, but then the water heater kicks on and the customer starts cooking on the stove and the gas lines aren't sized correctly. You have a pressure drop. Now you don't have enough pressure coming in, you don't have a pressure coming out. So while you're there, everything looks great, but in the middle of the night, the unit stops working or stops working correctly. You have incorrect combustion, you have all kinds of other issues. So these are things you have to be aware of. It's a pressure regulator that reduces pressure from inside reduces to the pressure out, and a solenoid valve. And the solenoid valve is only going to open during the proper sequence in the sequence of operation. Pressure regulator and solenoid valve all in one. Here we have our same exact valve set up on a unit. This would be our gas incoming, or incoming gas pressure, And on the side over here, we have our at least a 3-inch drip leg, and our gas supply is coming in the top. The idea is gas has to change direction to get to this combination gas valve. Any dirt, moisture, anything else would fall into the bottom. So a drip leg, dirt leg, depends on what part of the country you are, where they're called. So the gas changes directions, comes into our combination gas valve. On this side is our manifold, and our manifold then goes to our spuds and orifices where it mixes with primary air inside of our jets or burners. So this is our basic valve. Incoming pressure, output pressure, also called manifold pressure. Here's our solenoid, redundant solenoid, and our switch for on and off, and our gas pressure adjustment. So what we're going to do is set up to check gas pressure. This is the plug for outlet gas pressure, and this is going to go to our manifold. What we're going to do is set this up with our little tool. Same exact tool we use for refrigeration, air conditioning. Take this tool, press it on. Now I like to make sure I leave this plug on my tool so I don't accidentally forget it. The next thing I want to do is put my adapter in. So here is my adapter, just a threaded fitting. I'm going to thread it into this side like so. I would typically take a little small adjustable wrench and just add 1/2 turn of tight to make sure it's nice and secure. Then I'm going to use my manometer. So in this case, I like to use a digital manometer, and I have my hose and adapter. I'm going to press right here on the end of this tubing. Now that everything's set up, ready to go, I'll turn my manometer on, power it up, and I'm going to also zero this out. So what we're going to do next, we would check this with our unit running. We'd have to wait for the proper sequence in the sequence of operation. So we can't just wait for 24 volts, we need it in the proper sequence. Now I don't have anything hooked up here, but my wires would come in here, and I'd need to make sure this is in the on position. So I'd make sure I have 24 volts. When I have 24 volts, I should be getting gas pressure here. So it's a pressure regulator and a solenoid valve. When I have 24 volts, I should see gas pressure. Typically 3.5 inches water column for a manifold pressure on natural gas. Now if I do have 24 volts and I check it with my meter and I know, hey, I have 24 volts this location and I'm not getting any gas coming out, that's when you need to think I need to check incoming pressure. So at that point we would shut the system off. We would disconnect our hose. We would take this fitting back off. We would put this plug back where it goes. I would shut off my incoming gas so there's no gas coming into the unit. Then I would hook up my manometer to the inlet pressure side. Put my adapter back in on the new side. Put my manometer on the hose like so. Now I would turn the gas back on and I should immediately see inches of water column. If I don't have any pressure at all, I know, hey, there's an issue. Maybe the customer didn't pay their gas bill, but never accuse them of that. Go outside, look at the meter, see if it's been shut off. If it has been shut off, you go to the customer and you say, I'm sorry, man, we're having an issue with the supply company with the gas. You've got to contact the gas company to get them to service and open this gas valve up. Never accuse them about not paying the gas bill, about it being shut off, nothing like that. We just simply say you need to have the gas company check it. You always want to collect your service call, and then you can come back and finish checking everything else when they open that valve back up. Never accuse them. They're already going to feel bad as it is. You let them out of the hook. You give them an easy way out. Now, the other thing is, just because I see gas pressure coming in doesn't mean we're okay. I need to also go through the sequence of operation, have the system have a call for heat, and while the system is running, make sure I have plenty of gas pressure coming in. I've seen it before to where I had 7 inches of water column of gas pressure coming into this combination gas valve. but the line was so stopped up, as soon as the valve opened, my pressure dropped almost to zero. I didn't have enough gas pressure coming out. So these are why we think about this as being a solenoid valve and a pressure regulator. Pressure regulator is going to reduce the pressure from incoming to the output side, and the solenoid valve is going to send 24 volts only during the proper sequence. I've had technicians call me and saying, hey, I'm not getting any voltage to my gas valve. I said, well, did you wait for the proper sequence? He said, no. Well, you have to wait for the proper sequence. I'll get 24 volts here immediately when I have a spark igniter running, or if I have a hot surface igniter, the hot surface igniter will start getting hot first, and then a few seconds after, up to 30 seconds, I will then end up with 24 volts here. How do you know if you're getting 24 volts? You check it with your meter. This is a single stage combination gas valve, so it's fairly easy. I just take this cap off the top, and my adjustment is right here on the inside. This is where I'm going to adjust it. I screw this in the increased manifold pressure, and I back it out to decreased manifold pressure. Now, if I have it hooked up on the incoming pressure side and I adjust this, will you see any pressure difference here? No, you won't. So I would have to, if I'm going to adjust pressure, it has to be on this side. I like to use digital manometers. This is just one of many different brands and one of different types, but I love the digital manometers. Second to the digital manometer, I do like the old school Magna Helix. The problem is these are very sensitive. They're bouncing around in your truck and you'll damage the needle. They have to be calibrated, so it's a little bit of a pain. You also see a lot of people with the old Yellow Jacket kits. Now, I used these for a long time, but what I learned was there's no calibration on this. There's no way to know if this is actually in calibration. There's no way to adjust it. There's nowhere to send it to make sure we're still doing good. So I've moved away from this and gone to the digital. I have much better luck with that. All right, so this is one style. Now there's still a new valve that comes out. White Rogers brand uses a slightly different type of combination gas valve. What I'm going to do, good habits, take my tool back out, make sure I put this plug back in. I've seen people before, technicians, especially when they're first getting into the trade, they will leave this service plug out. They just forget. And everybody makes mistakes, everybody forgets. The problem is you leave this service plug out, you're having gas leaking into that combustion chamber, into that closet. It's going to be a big problem. If I leave this one out, as soon as I turn the gas on, it's filling this whole entire chamber nonstop. If I leave this side out, I'm only leaking gas when I actually have a call for heat. So we've seen this happen before at companies where the new guy comes in, forgets to put that plug back in, has a call for heating, we get 24 volts, the valve opens, gas comes to my manifold spuds and orifice, mixing with primary air into the jets and burners, across the hot surface igniter, igniting into a flame. Gas is also leaking out of this port, builds up through here, and you have an explosion. Fireball rolls that flame out. So it's kind of a big deal, something we want to take into consideration. Now we have another type of valve I want to point out to you, and it works exactly like the one that we just talked about. However, it's just a little different in how they do it. Here is my solenoid valve of my combination gas valve. My pressure regulator is on the side. It's a little bit smaller valve, so some of the manufacturers use this valve because it's easier to work with. We still have our pressure adjusting cap, looks exactly the same. If we unscrew this, there's our pressure cap, and this one has a different color end in it. So when you convert it to propane, usually you end up changing that piece out and the spring behind it. So this one actually may be hooked up for propane. We'd have to check to see. We still have our electronic on and off switch to shut it off. But there's something different about this when I'm checking the pressure. Here on these little ports right here, this is where we're going to be checking for a gas pressure. We have one for the incoming side and one over here for the output side. This is very important. So when you check gas pressure in this, it's going to be a little different. Here's our little ports we're going to be checking with. So what I use is this bit, which is a 3/32. I put this on the very end, and now when I loosen this, I only need to turn this 1/2 turn. A lot of people think you have to pull that completely out, but you don't. 1/2 turn and it opens this valve. Now what's different is I don't need the adapter with this. All I have is my hose, and it's going to slip over this port right here. Once it slides over this port, now we're ready to check gas pressure. So now that valve is open to my manifold pressure. So now I have a call for heating, 24 volts here, solenoid valve opens, pressure regulator is going to reduce pressure coming in to our correct manifold pressure coming out, and I can test that gas pressure with my digital manometer. So these are some of the new styles. I like this style because I don't have to keep my that adapter with me all the time, but you do have to remember still to close that back when you're done. The problem is, notice how this valve is angled. What I find is a lot of the manufacturers, when they use this, you're looking at the equipment like this, and there's going to be another wall here. So it's difficult looking on this back side to get to that to do it. Over time, you're going to do this enough where you can do it without having to personally see it. Another type of valve I want to discuss is our two-stage gas valve. Now, as equipment's getting more and more modern with more controls and technology, we're getting these two-stage combination gas valves. And I really do like these two-stage gas valves, so I just want to cover a few little points here. Instead of having just a pressure regulator and a solenoid valve, it has two different solenoid valves. One is going to be for high fire, and one's going to be for low fire. So if we look right here on this point here, we see high and low. So we're going to zoom in, and you can see the high fitting, high fire, and low fitting. This is where I adjust my pressure. So what we're going to have is a little fitting, that same one fits right inside of this port here, and I screw this in to increase pressure, and I back it out to decrease pressure. Then on low fire, I put it over here on the other side, and I can adjust low fire. So you're going to have to set the thermostat to call for heating for low stage to adjust your low pressure, and then you have to have it calling for high stage before you can adjust your high pressure. Now this particular valve, even though it's a two-stage valve, it uses the same adapter that we talked about at the beginning. So I'm going to use my same service wrench. Here's my incoming pressure. Here's my manifold. This is my out pressure. So that's the pressure I want to check. So put my service wrench in here. We take our little port out, and we're going to put our adapter right here on the manifold side. I can take my manometer, put my manometer on my port, turn it to my valve to the on position, wait for a call for heat. On high heat, I can adjust this side. On low heat, I can adjust this side here. It's very simple, very basic. If I don't have any gas pressure coming out, then I would move it to my input side to check gas pressure coming in. Very simple, not overcomplicated. People see extra stuff, extra wires, and they get concerned. Instead of having 2 wires to my combination gas valve, I end up with having 3 wires to my combination gas valve. So here we see C, 24 volt common, and then I have low, so here's low. So between low and common, 24 volts there, I'm on low fire. If I'm between high and common, 24 volts there, I'm on high fire. So 3 wires, 2 at a time. That's how we're energizing our combination gas valve. 2-stage gas valves, nothing to be afraid of. Multiple different brands of gas valves out there. They all work that same way. You got to remember, pressure regulator reduces the pressure, which is adjustable, and a solenoid valve that's only going to open during the proper sequence.